So this is a recap from your activity. The degree of your polynomial is its highest exponent on your variable, so this one's degree 5, and the leading coefficient is the coefficient on that term, -8. This one's degree 3, it's out of order, but look for your highest exponent with the leading coefficient of 6. When you worked through your activity, you hopefully noticed some patterns. So even degree polynomials and odd degree polynomials had graph shapes that looked differently. And furthermore, whether the leading coefficient was positive or negative affected your graph shape too. So overall, even functions, remember, are even numbered degrees, like x to the 4th, x to the 2nd, odd number degrees, x to the 1st, 3rd, 5th. An even function has ends that point the same direction when you look at its graph, either both up or both down. An odd function has ends that point opposite ways, so one up, one down. So an even polynomial with a positive leading coefficient would be like 5x to the 4th plus 3. Say you switch that to a negative leading coefficient. How does that affect your graph shape? So even means both ends point the same direction. If it's a positive leading coefficient, both ends are going to point up. We don't care what happens in the middle. We don't know what happens in the middle. And then if it's a negative leading coefficient, both ends will point down instead. An odd degree polynomial with a positive leading coefficient would be something like that. And one with a negative leading coefficient, let's just switch it to negative 5x cubed. We'll throw a plus 2x squared on there. If it's a positive leading coefficient, it's going to go upwards as you go towards the right, so you'd say it's upwards on the right side, down on the left side. A negative leading coefficient flips it around so that it is going to be up on the left end and down on the right end, which you can kind of remember that because think about straight lines. Like if you have a line with a positive slope, it's going to go up as you go towards the right. One that's negative goes down. Same thing with your leading coefficients on degrees that are higher than 1. We do have formal mathematical notation for describing that in behavior besides just up on the left end and down on the right end. We're going to write them in terms of x and y. So thinking about your coordinate plane, you can describe the right end of your graph by thinking about the x values get infinitely bigger, bigger, bigger in a positive direction, and the left side as x values go towards negative infinity. In terms of does it go up or down, that's your y values, which if it's going upwards on an end, we're thinking about our y values approaching positive infinity, and downwards on an end, our y values are approaching negative infinity. So let's do an example here. So if I sketch in a graph, let's describe its end behavior using our formal mathematical notation. So just in words, I could say that the left side of this function's graph is going upwards and the right end is going downwards. Say that we're talking about the left side of our graph, we want to say as we look at the x values that approach negative infinity, because if you go towards the left on your x-axis, your x values are getting smaller and smaller and smaller. Then, if our left end is up, we need to say what happens to our y values. They're going upwards, bigger and bigger and bigger towards positive infinity. So that would describe your left end of your graph. You could also say f of x instead of y. To describe the right end of your graph, you would say as your x values approach infinity or positive infinity, because you go toward the right, your x values are getting bigger and bigger and bigger in the positive direction. And then in this one, our y values are going downwards towards negative infinity. So that is equivalent to those words in our mathematical notation. So let's practice this a little bit. We don't have a graph, so we're also going to practice our end behavior. This is a degree 3 polynomial with a leading coefficient of 1, because that's a 1x cubed. So it's an odd degree with a positive leading coefficient. So you could look back at your chart, but that means ends are going opposite directions, and it's going to go up as you go towards the right since it's a positive leading coefficient. So I'm going to write it in words here. We know my left end is going downwards, my right end's going upwards. To describe going to the left, I'm talking about my x values approaching negative infinity, and my y values are going down towards negative infinity too. On the right side means x's are approaching infinity, if my y values are going towards infinity, that indicates it's going up. So let's look at another one here. This one is degree 4 because that's my highest term's exponent, and it has a leading coefficient of -1. So it's even degree, both ends will be pointing the same way, and it's negative, so that means both ends will be pointing down. So I'm going to say my left end points down and my right end points down. How do I say that with my new mathematical notation? Well, anytime I'm describing going and talking about the left side of my graph, I want to say as my x values are approaching -infinity, then my y values in this case are going downwards towards -infinity too. And then as my x values approach positive infinity, as I go towards the right, my y values are approaching -infinity as well. All right, this one you have a degree 5 polynomial, and it has a leading coefficient of -1. So it's an odd degree. Both ends are going to go opposite directions, and negative leading coefficient means that as I go towards the right side of my graph, it's going down, just like a line with a negative slope. So right side is down and the left end is up. I switched the order I wrote them in this time. So if I'm describing going towards the right, that means my x values are going towards positive infinity. And then to say that my y values are going down, they approach -infinity. On the left side, think my x's are getting smaller. My y values are going upwards towards positive infinity. We are going to start with a simple polynomial and change it up so that it meets some shape requirements. So I'm going to take this function that represents a horizontal line and change up its shape by adding another term to it so that it goes up on the left and down on the right. So that means it's got to be odd degree, and it will have to have a negative leading coefficient. So whatever term I add to this is going to have to be an odd degree term with a negative leading coefficient. So let's start with adding -3x to the third. There are an infinite number of options, but that's what I picked. Okay, if it needs to now go up on both ends, it's got to be an even degree with a positive leading coefficient. So let's take my function that I have right now, my f of x equals 2 plus -3x cubed, and then I need to add a term that is bigger degree, and it's got to be even with a positive leading coefficient. I'm feeling even degree of 40 and just a leading coefficient of 1. Now I'm going to take that and change it so it goes down on both ends, so still an even degree, and it's going to have a negative leading coefficient this time. I'm going to copy and paste this. So I'm going to go with a negative something. Let's go -31, x to the 42nd. Now remember that degree has to be larger than the previous ones or it won't actually change the degree of your overall polynomial.